Hi, my project is on developing a model to prevent inventory theft in a retail store. The problem: with losses for U.S. retailers exceeding $44.2 billion annually, the problem of retail shrink, which refers to inventory loss due to employee theft, shoplifting, administrative errors, and vendor fraud, is substantial. With large retail stores, however, having this inventory stolen is figured into the cost of doing business. But in a small, locally owned store, this problem can be the difference in that store either making money or going out of business. The project. When thinking about this project at the beginning of the semester, I knew that I wanted to do a project on store theft, because since I have worked in retail. However, I could not find one that would fit my purposes, so I made one up. So this is a fictional store. In my mind, I see it as a small one owner business in a small town. While this store is financially sound, they are having some issues with theft. Since I could not find a store that would have data online with inventory, I had to create my own data set. This data has 100 different types of inventory. The goal of this project is to predict what product is likely to be stolen and who is stealing it, either customer or employee, and then create a plan to keep that from happening. The next slide will show the data diagram that demonstrates how data flows through the system. This slide is on the data diagram. It shows where the data and how it moves through the system. It begins with the receiving of the packing slip and goes all the way to the reports that are being printed. It also shows where the data is being stored and how it is protected. The method. To do this project, I will be using Microsoft SQL Server Management Studio to actually create the database, and then use JMP and R to analyze the data and to create the data visualizations so that the stakeholders can get an idea of what is happening with the inventory in the store. The slide has the data dictionary. The data dictionary has the field names, which include the SKU RFID number, category, subcategory, BOM, which stands for beginning of month, sold, EOM, the end of month, the variance, the cashier, the front door, and the back door. It also has the data type, which does include how the data must be presented. Is it integer, which would be it has to be a number, or variable characters, which says that it can be either numbers or letters or a combination of both. The next is a description, which gives a short description of what the data is going to be in that particular field. And then the last one is the constraint. As you know, the SKU number is the primary key, and all of the rest of them are not null. So they must have some data in each of the data cells. Checking for null values. In the data dictionary, we said that there could not be any null values. So before we can begin analyzing the data, we must ensure that that is true. So using both R and a Microsoft SQL Server Management Studio, you can see that there are no null values in this data set. Now that we have been ensured that the data is correct and in the right format, we're going to look using R and look at the data itself. If you look at the mean and under best BOM, which is the beginning of the month, you see that the mean for that month was 35.24. So there were 35.24 average of product from each subcategory. If you look at the sold, it shows that the mean for this month was 16.07, and at the end of the month, the mean was 13.15, with the variance mean being 6.02. And if you also look at the front door, you can see that of that mean, 3.45 product went through the front door without being purchased, and then the back door is 2.57 of that. This is the distribution of sold, variance, front door, and back door. At the distributions of the variables, it shows that all four of them are right skewed. Notice that the outlier box plot to the right of each histogram indicates possible outliers. There is no reason to believe that these records are faulty, so they will be left in the analysis. The scatter plot matrix. When looking at a scatter plot matrix, it is easy to see the sold and cashier are strongly related to each other, and they should be, as whatever is sold must go through the cashier, while variance and backdoor and front door are related to each other, but they're not as strong. The next step is looking at the data and predicting what will happen. Using jump fit model, the store will try and predict how much product will sell in each month by looking at the BOM, or beginning of the month, and what is sold. Looking at the p-values, end of month, beginning of month, and sold are linearly related, as the p-value in each instance is low and the same. The red shading shows where the slope will be depending on the change in variables. Now look at predicting how much product is going out the back door and the front door without being purchased. It shows that the variables of variance and back door are linearly related, as are the front door and variance, and it shows the slope range if the data were to change. Another statistic to look at is R squared, the coefficient of determination. R squared provides a measure of the strength of the linear relation between the response and the predictor. In simple linear regression, R squared is the square of the correlation coefficient R. The closer R squared is to 1, the more variation that is explained by the model. The larger the R squared, the better the regression model fits the observations. Since R squared for the response end of month with the variables beginning of month and sold is 75.50725% of the variation of the response, end of month is explained by the variables beginning of month and sold. Looking at the response variance of the variables of backdoor, R squared is 68.9678% of the variation of the response. Variance is explained by the variable backdoor. Next, looking at the response variance of the variable front door, it shows that the 75.7863% of the variation of the response variance is explained by the variable front door. First thing the store will need to examine is comparing the inventory they have at the beginning of the month, which is the blue, to how much of it was sold that month, which is the red. This will give them a good idea of what product category sells best and which do not. Looking at the visualization, it shows that while the store has a good stock of dried flowers, it did not sell any for this month. This would be a trend the store manager might want to track for several months to see if it continues, and then consider discontinuing the product because the customers are not purchasing the dried flowers. However, looking at the other end of the spectrum, seasonal products sell great as the visualization shows. The store sells out of almost all the product that they have in stock, so they should consider stocking more of the seasonal since it is a product that the customers purchase. Another product that is popular is towels. While it doesn't do as well as the seasonal product, and the store has a good supply of towels, the customers do seem to be purchasing them. The next visualization to look at is to look at the product at the beginning of the month. Again, it's red. What was sold this month, which is again blue, and the product that was not there when inventory was done at the end of the month, which is green. So that would be the product that has been stolen. This brings into focus what is going on in the store. This visualization is showing that belts, board games, dried flowers, game consoles, and jackets, PlayStation games, and wine have more products stolen than the store sells, which means that in those areas the security is inadequate, and the store will need to train their cameras on those areas of the store. They may also consider moving the product to a different part of the store to make it harder and less attractive to thieves. However, on a good note, in this month, none of the seasonal products were stolen, so it shows that either it is very popular, that it doesn't stay on the shelves long enough for it to be stolen, or that the security in place discourages the theft. When looking at jewelry, while there is a lot of jewelry in stock, and it is not the best seller in the store, but very little of it is stolen, which again proves that in that area of the store, the security is pretty good. But since some of it is being stolen, the store may want to look at ways to tweak that security to improve it. The third visualization breaks down the information even further. It looks at the product that is stolen, how much of it is going through the front door, the blue, and how much of it is going through the back door, the red. This visualization shows that beer, belts, board games, candles, clothing, cut flowers, dried flowers, jewelry, potted plants, tote bags, and purses, toys, and wine are being stolen more by customers than by employees. However, towels are equally stolen by customers and by employees. Whereas card games, ceramics, computer games, game consoles, jackets, PlayStation games, and the wallets are being stolen more by employees than by customers. This is where the cameras will come into play. As the product is taken out through the back door, it will timestamp the video so that the manager can look at it and see which employee or employees are involved in the theft and terminate them. Future work. Number one, each month monitor the items that are stolen and track them to see what changes month to month. Number two, move some of the inventory to other locations within the store to see if that affects what is stolen each month. 3. Use the cameras to pinpoint the employee or employees that are stealing and terminate them. The hardest part of this data project was finding a data set that I knew would do what I wanted it to do. I could not find the data set that would meet all my needs, so what I ended up doing was creating my own data set, which unfortunately brought along its own set of problems, such as trying to make sure that the data would work and that I would be able to do the visualizations and other things I needed to do to make this project a success. Probably the thing I found the most interesting was the one thing I was worried about the most, which was creating the database. I was really worried about doing it because I hadn't had much practice at it, but when I got into it, I discovered how much I enjoyed doing it and how much I like working on it. I also like working on R, which because I like putting in the correct codes and watching it do what I wanted it to do. And these are the references um, that I used to make this presentation. Thank you for watching this presentation. I hope you enjoyed it.